All right, so I had to pause that last video and then redo it, then do this last one again. So it is 3 videos now. So this one is just going to be about solving radical equations. And we know it's an equation because it's an equal sign. So it's something is equal to something else. That is an equation with the equal sign. All right, so before we get started on this, if I give you the square root of 2 and I say it's equal to the square root of x, and I say, well, what number does x have to be? Hopefully this is just intuitive that you would say, well, the x has to be equal to 2 because if x is any other number, then that means that it will be the square root of 1 or the square root of 3, square root of 4, etc., and not the square root of 2, so they wouldn't be identical. So anytime that you have 2 radicals that have the same index, so here we have an index of 2 and an index of 2, and they're equal to each other, we can just go ahead and take the insides and set them equal. Because if the insides are not equal to each other, then it's impossible for them to actually be equal. Because then over here, if we said x is equal to 3, well, then we would have the square root of 2 is equal to the square root of 3, which we know is not true. So once we have 2 square roots that are equal to each other, we simply just set them equal. Right now, after you do this, we can then go ahead and solve. It's just a regular algebraic equation. So we will add over 2k. So we're going to move all of our variables to one side, and that means we then have to move all of our numbers to the other. So these will cancel out, and these will cancel out. So I'm left with negative k plus 2k, which is just k, and then 9 minus 8, which is 1. And that's our final answer. Remember, I want you guys to get into the habit of plugging it in. So the square root of 8 minus 1 is this equal to the square root of 9 minus 2 times 1. Well, 8 minus 1 is 7, so the square root of 7 is this equal to 2 times 1 is 2, 9 minus 2 is also 7. So yes, they are equal. All right, so for this problem here, now that we have just one radical and it's not equal to anything, we have to do it a little bit differently. We have to isolate our radical, right? Meaning we have to get the radical all by itself. So if something's being multiplied or divided or added or subtracted, we have to clear it all out until we get just the radical by itself. So that means we need to get rid of this minus 10. We need to move it to the other side so we isolate our radical. So that will then give me the square root of n over 10 is equal to 10. And now we have completely isolated this radical. There's nothing else that's being done to it. This division's inside of the radical, so that's different than isolating it. And now, we've learned before that the square root of 2 squared is equal to 2. The square root of 3 squared is equal to 3. The square root of 4 squared is equal to 4. And the square root of any number squared is equal to that number. So square roots and squares are inverse operations. They undo each other. So that means we have the square root. If we want to get rid of that, we need to square it. So we square one side, we have to square the other. So then we get n over 10 is equal to 10 squared, which is 100. And now we just have a regular algebraic equation. So to get rid of the division on the n, that means we need to multiply each side by 10. And when we multiply 100 by 10, n is then equal to 1,000. Right? And then we can plug it back into the original problem to make sure that this is correct. 1,000 divided by 10 is 100. The square root of 100 is 10. 10 minus 10 is 0. Check. All right, so once again, we have a radical and only one of them, so that means we need to isolate it. So I add the 1 to both sides. So then I get the square root of 3x plus 10 is equal to 1. Well, we know the inverse operation of a square root is our raising it to a power, so then we will square each side. That will then give me 3x plus 10 is equal to 1 squared, which is still just 1. And now we need to solve this regular algebraic equation. We subtract 10, so 3x is equal to negative 9. We then will divide each side by 3, and x is then equal to negative 3. Right? Then we check to see, does it work? So 3 times negative 3 is negative 9. Negative 9 plus 10 is 1. The square root of 1 is 1. And 1 minus 1 is 0. Check. All right, and this is the last problem, and then we're done with this video. All right, so this is the last video for us to do. Luckily for this one, it's already isolated, so it saves us some time. So we need to just get rid of this radical first then, and we do that by squaring it. So 3 squared is 9, so 9 is equal to 2n plus 19. All right, then now we have a regular algebraic equation, so we need to solve for m, so I'm going to subtract 19 from both sides. So 2n is equal to negative 10. And then I'll divide each side by 2. And m is then equal to -5. All right, then we check. 2 times -5 is -10. -10 plus 19 is 9. Square root of 9 is 3. 3 is equal to 3. Check. All right, that is it for this video. And that's it for the review.